In this video, we're going to be learning about the signs of trig functions in different quadrants and also what reference angles are and why they're useful. So to investigate the signs of each trig function in each quadrant, we're going to pick a point in each quadrant and then generalize that to all points in the quadrant. So our first one we're going to start with is quadrant 1. So let's pick an easy point in quadrant 1. Let's pick the point 3, 4, because that's going to make a nice 3, 4, 5 triangle. So if we have this triangle, we've got theta right here. This side of the triangle is going to be positive 3. This side's positive 4. And then our hypotenuse is 5 because it's a Pythagorean triple. So what we're going to do is figure out what sine, cosine, and tangent are, and then see whether they're positive or negative in this quadrant. So if we have a point in quadrant 1, and we picked 3, 4, but we could have picked any point, then sine, remember if you write SOHCAHTOA, sine is opposite over hypotenuse, so our sine is 4 over 5. Cosine's adjacent over hypotenuse, so cosine is 3 over 5. And tangent is opposite over adjacent, so 4 over 3. Then we have our other three functions. So remember we have cosecant, which is kind of paired with sine. We have secant, which is paired with cosine. And we have cotangent, which is paired with tangent. To find cosecant, we just flip sine. So we say 5 over 4. To find secant, we just flip cosine, so 5 over 3. And to find cotangent, we flip tangent, so 3 over 4. So notice if sine is positive, then cosecant's got to be positive. If cosine's positive, then secant has to be positive. And if tangent's positive, then cotangent has to be positive because all you're doing is flipping. So we realize in this quadrant 1 that all of the functions are positive. Let's see what happens in quadrant 2. So again, in quadrant 2, that means we're over in our second quadrant, so over here. Let's again pick an easy point so that we don't have to deal with any crazy numbers. So let's pick the point negative 3, 4, but remember we could have picked any point. So that means this side is going to be negative 3, this side will be positive 4, and our hypotenuse will still be a positive 5. So now if we figure out sine, cosine, and tangent, let's see if they are positive or negative in this case. So sine, opposite over hypotenuse, 4 over 5. So that stays positive. Cosine, adjacent over hypotenuse, so negative 3 now over 5. And tangent is opposite, so 4 over negative 3. Now we find our partner ones that we can flip. So cosecant, secant, and cotangent. So let's flip the other one. So opposite of sine would be 5 over 4. Flipped for cosine would be 5 over negative 3. And flip for cotangent, for tangent would be negative 3 over 4. So now notice sine and cosecant are the only ones that are positive. So in this case, we only have sine is positive. And you could also say and cosecant, but we kind of just forget about it because it's obvious if sine is positive, the flipped version, cosecant, would also be positive. Now let's try for quadrant 3. In quadrant 3, we could pick any point, but let's just pick one that's easier for us. So let's pick the point negative 3, negative 4, which is down here in quadrant 3. And we'll make a triangle out of it. So here's theta. And now let's see what we end up with. So now, here's negative 3, here's negative 4. Both of these now are negative. And then our hypotenuse is still a positive 5 if we use Pythagorean theorem. So let's figure out sine, cosine, and tangent. As usual, sine's opposite over hypotenuse. So we have negative 4 over 5. Cosine is adjacent over hypotenuse, so negative 3 over 5. tangents opposite over adjacent. So -4 over -3, which turns into +4 over 3. Now we have our three other functions. We have to remember to flip the fraction. So that is cosecant of theta, secant of theta, and cotangent of theta. So now let's flip what we have. So we have 5 over -4, 5 over -3, and +3 over 4. So now in this quadrant, we realize that tangent and cotangent are the only two that are positive. So here we can say tangent is positive, and obviously also cotangent, but that's kind of an afterthought. One more time, so let's try quadrant 4. So let's pick a point down here, and again, we're going to pick a point that just makes our lives easier. So we've got theta, and now we're going to pick the point 3, -4. So now here's a +3. We go down 4, and our hypotenuse is still 5. Again, we're going to find sine of theta, cosine theta, and tangent theta. So we've got -4 over 5, we've got 3 over 5, and we've got -4 over 3. Then we have our three flipped functions. So let's flip sine to get 5 over -4. We'll flip cosine to get 5 over 3, and we'll flip cotangent to get -3 over 4. So now only cosine is positive and secant. So if we look back, in the first quadrant, every function was positive. In the second quadrant, only sine. In the third quadrant, only tangent. And in the fourth quadrant, only cosine. So what we can do is figure out a way to remember this. So if we ask which one is positive when we're looking at all of our quadrants, here, all of them are positive. Here's just sine is positive. Here, tangent is positive. And here, cosine is positive. So if you take the first letter, so like all would be A, sine, S, T for tan, and C for cosine, we can remember this as all students take calculus. So if you start in quadrant 1, then we'd go A, S, T, C as we move around. My pre-calc teacher used to tell us all students take cocaine is how her son remembered it, but whichever one works for you. Next up, we have our reference angles. So reference angles are really, really useful, which we'll figure out more in the next video. So all a reference angle is the distance from the x-axis. So if we have any angle, so let's say we've got one angle over here, we've got another angle over here, you've got another angle over here, and we have another angle over here. If we find the shortest distance to the x-axis, we call that the reference angle. So in this case, here's our reference angle. For the blue angle, here's our reference angle. For the green angle, that's the shortest distance. And for the orange angle, that's the shortest distance. So what we do is focus on this x-axis, and we figure out what's the shortest distance. That short distance is going to be the reference angle. So let's try two examples. So let's say we have 330 degrees. The first thing you need to do is figure out where 330 degrees is. We know if we go around, we go from 90 to 180 to 270. All the way around is 360, so we're just a little bit short of that. So here is 330 degrees. Now to figure out the reference angle, we figure out the shortest distance to the x-axis. So right here is going to give us the shortest distance. If I know the full thing is 360, the shortest distance from 330 to 360 is 30 degrees. That's the difference. So our reference angle is 30 degrees, which is going to become really useful because we're going to learn certain things about the trig functions for 30 degrees are really similar to the trig functions for 330 degrees. Let's try one more. So let's try negative 100 degrees. So we know if we move negative, we're actually moving clockwise. So we're moving in the opposite direction. If I move this far, I'm at 90. So I'm just going to move a little bit more so that I get to negative 100. Now I try to figure out the shortest path to get to the x-axis. So that's going to be this green area right here. If I kept moving, that brings me to negative 180. So the distance, the shortest distance from negative 100 to negative 180 is 80 degrees. So in this case, our reference angle is 80 degrees. And those are going to be really, really useful for us in the next video.